Hi, thanks for joining us on another episode of Space Nuts. My name is Andrew Dunkley, your host. Hope you're well. Coming up this week, we're going to answer questions about short-sighted science, why things spin, and what we would ask aliens if we had the opportunity to do so. That's all coming up on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9... Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Okay, Fred, time for our Q&A segment. This is where we answer questions from the audience. There's been a couple that I've been sitting on lately because I thought they required homework, and I hope you did your homework, Fred. I had to do homework on a couple of these. We'll start off by hearing from one of our regular sender-inners, and that's Buddy.
Hey, guys, this is Buddy from Oregon. Do you think that mainstream science sometimes is stuck in a rut? It seems like they fail to see obvious things because it's kind of off their kilter from their speciality. And I'm just going to use one example of the blindness of science is sometimes some of the smartest scientists in the world. You've even said so, Fred, NASA. Okay, they spent $10 million to come up with a pen that would write in space. Fantastic. You know how the Russians solved it? A pencil. Okay, that was right there. Nobody. I mean, come on. Anyways, thanks, guys. Love the show. Keep up the good work, and thanks for your patience.
I love Buddy's laugh.
Yeah,
because
great.
It is funny. I think there's a lot more to it than that. I think, you know, the idea of the space pen was good for some reasons, but I think there's a bit of an urban myth angle going on there too. But it's.
Let me tell you the true story, Andrew.
Okay, yeah, I'd love to hear it. I hope it doesn't spoil my research.
I do too. It is an urban myth, and Buddy should know that. Yes, you do. So what happened was, in the early days of human space flight, both the Soviet Union and NASA, both of them used pencils. And they were propelling pencils, so they didn't have to sharpen them. But it turns out that fragments of pencil lead can float around in space, and they're not very good for you. You don't want to get them to get in the works. And it was not actually NASA that developed the space pen. It was a company called the Fisher Pen Company, and they did invest. We don't know how much it was, but it's of order $1 million. It wasn't NASA who put the money into it. I think in the end, NASA did use some of those Fisher pens, as did Roscosmos. The Soviets also used them. So, it puts the urban myth to bed because that's what happened. Yeah, and it's a lot. It's a much less entertaining story. Is what actually happened. The urban myth's a lot more fun.
Yeah, there's a few great urban myths from the space race era. Mr. Gorski comes to mind, but we won't go there.
That's right.
Apparently, it was a company in Houston, Tycam Engineering Manufacturing Incorporated, in 1965 that came up with 34 mechanical pencils.
They were the pencils.
At a cost of $4,382.50. They were $128.89 each. Per pencil. Yeah. Each pencil.
But they were
That's a very expensive pencil.
Pretty flashy pencils.
And which reminds me of something before we go on, Fred. Did you hear that they found a cache of pencils that used to belong to William Shakespeare? But he had this. It's true. He had this habit. No, I'm serious. He had this habit of chewing his pencils, so they couldn't tell if it was to be or not to be.
I had a feeling this might be going somewhere like that. Wow, that's very, very nice, is that?
That's a rip of that one.
Yeah. But just going back to the thrust of Buddy's question, ignoring urban myths, I think he's got a good point. And scientists do tend to at least try and be open-minded. But it is, the classic example of what Buddy's talking about is dark matter. We think that the idea that there are these subatomic particles whose nature we haven't uncovered yet, permeating the universe, we think that is the best fit to the information. But a lot of people, I think, have got fixated on that idea, and there's really good reasons for doing that. It's not just the individual galaxies rotating too fast that tells us dark matter is there. It's the whole geometrical structure of the universe that can only work the way it does if you've got this dark matter component. So we're led very strongly in that direction. But you do still need to keep an open mind. And there are a few scientists who say, well, maybe dark matter's there, but maybe it's something else. And many of them are researching into MOND, modified Newtonian dynamics. One of our listeners, as you probably know, Peter Verweyen, shout out for Peter there, who is actually doing his PhD on MOND, on the idea that we've got our view of acceleration wrong. That Newtonian dynamics at very low accelerations breaks down. And that in itself is a fascinating idea. There might be, we have to try and understand that. But there are ways in which that can satisfy the need for dark matter without it being dark matter. There are still problems with it. It doesn't fit some of the observations that we made. But that's, I suppose, comparable with the big problem with dark matter, which is we can't find it. We don't know what it is.
Yeah.
So Buddy's point is well made, even though
it is, and I can back.
It's a good one.
I can back Buddy up with a few other things that have happened in science in general. Utsi, the Iceman they found in the Alps, who'd been there for thousands of years. When they first tried to find out why he died, they missed the arrowhead in his shoulder. A second team of scientists found that. Yeah. The colour of the universe. I love dredging this one up for you, Fred. The colour of the universe. Completely missed that one.
I remember that.
Yeah, it's beige, but they said it was aqua originally, wasn't it? It is. George Mendel. I don't know if you've heard of this bloke. He was the first one to pose the theory of genetic inheritance. Passing things on to your children. That was ignored in science initially. Yeah. Ignace Semmelweis was the one who suggested washing your hands would reduce the mortality rate in hospitals. That was ignored. And Ludwig Boltzmann, who came up with atom formulas, he was ignored on the basis that his theories destroyed everyone else's work.
Yeah. There's a classic one from astronomy as well, and that is the discovery of nebulium, there's good reason for it. When people started first looking at nebulae, gas clouds, with a spectrometer or spectroscope to identify the elements that are in there, which you do by the wavelengths of light that they radiate, they found this stuff that they couldn't pin down. Everything else, hydrogen, carbon, iron, everything else fit what we find in the laboratory. But there was one species that these bright lines in the spectrum of a nebula, which simply didn't fit anything. So nebulium was postulated in the 1860s, late 1860s, 1870s, and it wasn't debunked until 1928, I think. So
wow,
it was 50 years. And it turns out that what it is atoms behaving very differently in the vacuum of space from what they do in the laboratory on Earth, because we can't create a vacuum anything like as good. And so atoms, they emit what are called forbidden lines. It's a really lovely story. Forbidden lines are lines that are forbidden when you emission lines, bright lines in the spectrum that are forbidden when you try and measure them on Earth. But in the vacuum of space, they're all possible. And that's what they were. It's a very clever man called Ira Bowen who made that discovery. And it was. We'd all been barking up the wrong tree for a long, long time. Not me, I wasn't for that. We've got to move on, Andrew, because I'm short of time.
Yes. All right. I think we'll just do one more question because you are about to leave us. But thank you, Buddy. We might just do this one because I think it'll be quick and easy. And apologies to Robert, who asked us a question about what we'd ask aliens. We'll move that over to next week.
Next week.
Apologies for that.
0G, and I feel
Space Nuts.
We've got a question from Lynn in Victoria in Australia. Probably a terribly simple question, she says, but I've never heard it discussed. Why does everything in the universe insist on spinning, rotating, orbiting around itself, or seemingly anything else in its vicinity? Suns, moons, planets, solar systems, galaxies, everything is twirling about with gay abandon. Why is it so?
Yeah, I love the gay abandon line because that's exactly what it looks like. And Lynn is quite right. Pretty well everything rotates. And it's a feature of the way everything is formed, because all of these things in some way or another, and let's think about stars in particular because that's the easiest one to deal with, they all involve, when they're formed, they all involve a collapse, something being pulled together by its own gravity. In the case of a star, you start off with a cloud, a nebula like we've just been discussing, a cloud of gas and dust, which essentially starts compressing itself by its own gravity, and that's the beginning of star formation. Within that cloud that's compressing, there will be little swirls and eddies set up, because that's the way gases move. It's all about gas dynamics, is this. As gases move, they set up these swirls, and eventually those swirls, it turns out that there is a preferred direction, clockwise or anti-clockwise, as those swirls all come together. And as the collapse takes place, you get the conservation of angular momentum, which means as this thing gets smaller, this cloud of gas gets smaller because it's collapsing, it spins faster, and it takes on whatever the predominant direction is of those swirls. So it can't really collapse without starting to spin. And collapsing is the basic mechanism by which things form, whether they're stars or even galaxies. So galaxies rotate as well, probably because they started off from huge clouds of gas and dust. Individual stars would form within them, but there will be an overall rotation direction which will be picked up by the galaxy. It is amazing. Planets the same. Planets swirl because they swirl with the rotation of the protoplanetary disk that we talked about earlier. So a great question, Lynn, but there is a mechanism that would cause that.
Well, it's hard to imagine that the universe would just be, a deathly still pond. Nothing doesn't move, really.
Yeah. I mean, if planets aren't rotating around, revolving around a star, they just fall into the star because gravity would pull them in. It's the balance between their motion and gravity that keeps everything on track.
Yeah, just orbital mechanics.
Yep.
Indeed. All right, thank you, Lynn. Lovely to hear from you. Unfortunately, that's where we're going to end it for this week. But we do appreciate you sending in your questions, and please keep them coming. We really would love to answer all your questions. We often get duplications of questions, so if we don't answer yours, it's because someone else asked it before you or after you. Sometimes we don't have these things in chronological order sometimes. But please send them in via our website, spacenuts.io, and click on the AMA tab or the Send Us Your Message tab on the right-hand side of the home page. And have a look around while you're there. Maybe you'd like to become a patron, and maybe you'd like to become a subscriber if you'd like to follow us on YouTube, for example. Subscriptions are welcome. They're free. Just press the subscribe button and add yourself to the list, and you can catch video editions of Space Nuts on YouTube. Fred, that's where we're going to wrap it up for another week. Thank you, kind sir.
It's a pleasure. Always good to talk, Andrew, and we'll talk again soon.
We will indeed. Fred Watson, astronomer at large, part of the team here at Space Nuts, and thanks to Hugh in the studio for being Hugh in the studio. And from me, Andrew Dunkley, thanks again for your company. Catch you on the very next episode of Space Nuts. Bye for now.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at bytes.com. This has been another quality podcast production from bytes.com.